Hey everyone, today we are going to look at solving a system of equations by substitution. Alright, so first, if you look at the floor when we graph, that means that the solution is where the lines cross. So there's another way to find this substitution that we'll be looking at. So what does it mean to use substitution? So substitution is like to replace. So what we're really doing is we're figuring out one of our variables and replacing it in the other equation. So if you remember, when we did literal equations, we didn't solve for a number, we solved when we had multiple variables. So we're doing this the same way. I have these two equations. I want to replace one of my variables with the variable from the other one. So replace variable with given value. So I want to get either x or y by itself. When I say x or y, a lot of times we'll see y, but it can be either one. In this case, we already have y by itself. So, okay, replace variable with given value. So this tells me y equals x minus 1. So let's say I had y equals 1. I could figure out x by, I have no idea what the actual value is. I could figure out x by putting 1 into y. 3. And, oh, that's amazing that that number actually worked. So, in this case, I had a number, and I solved it to get another number. Now, we're not going to do that, because we don't have a number for y. We have an expression for y. So, we're going to say that y is x minus 1. So, instead of y, I'm going to write x minus 1. So, now that I only have one variable, I can figure out what that variable is. And this time I actually will get a number. So let's see, I'm going to simplify. So I got to distribute that. So I got 4x. So distribute your parentheses. Combine my terms. 4x minus 3x, that's x plus 3 equals negative 1. And then when I get the variable by itself, okay, so I got x plus 3 equals negative 1. Okay, so I got x plus 3 equals negative 1. And I want to subtract 3 from both sides. I get x equals negative 4. Now I know that x equals negative 4. And I know that y equals x minus 1. So now that I know a number for x, I can figure out what that number is for y. So let's see, I know that x equals negative 4. Technically you can use either equation, but either way it has to be one of the original equations. So I could use this top one if I wanted, but to make my math more simple, I'm just going to use the bottom one. So I'm going to use y equals x minus 1. Okay, so now I'm going to take this negative 4 and put it there. So yeah, y equals negative 4 minus 1. Okay, y equals negative 5. Okay, so now I have a y value and an x value, negative 4 comma negative 5. And let me show you what this might be on a graph. So when we're talking about graphing, Desmos is our friend. Now we do want to be able to graph by hand. So let's put our point on there. So we got negative 4 comma negative 5. Oops. I didn't realize I would do that. Okay, so I got my point. So since we know this is the solution, we can guess that this is going to be where the lines are going to cross. So this is our solution. Okay. So let me type in our equations. So let's see, 4x minus 3y equals negative 1. 3y equals negative 1. And y equals x minus 1. And you can see, like we thought, this is where our lines cross. So this is a good way to check if you got your substitution correct. So here's another way to check. I know that my solution was negative 4 comma negative 5. So I'm going to cut. Oops. 4. Another way to check it is that I know that this should work in both equations. So I'm going to replace my y and my x with what I just figured out. So I got -5 equals -4 minus 1. And this is what we figured it out, and so it should come out right? So -5 equals -5. Okay, does -5 equal -5? Yes! So this means it's true. Cool, we're done. All right, so let's try it on the other one. So we got 4 times -4 minus 3 times -5 equals -1, right? This one's a little harder. So 4 times -4, that's -16. -3 times -5, that's 15. And we get -1 equals -1. And as we know, this is also true. So if it were false, I would get something like -1 equals 4. That's not true. Sad face. But when they are equal, yay, we got something that's right. Okay. So looking here, let's zoom in so we can actually see what we are doing. Okay, so we're using substitution to solve the following system. What is the result of the first step? So if you remember, what was our first step? So our first step was to replace the variable with the given value. Now this is only the case if x or y is already by itself. And if we look here, wow, how convenient, x is already by itself. So my first step then would be to take this and replace x with it. So let's see, 6y plus 3 plus 2y equals 5. So in this case, I had to use x instead of y, like the one above. So the first step would be here. I almost clicked the wrong one. So I put parentheses just to show that this is x, but in this case, parentheses don't really matter. However, if I had like 2x, that would make a difference. So I'd have to say 2 times 6y plus 3. So it's a good practice to put those parentheses. All right, so let's work through our next problem. And I want to use a different color. Okay. All right, so we're going to work through another system using substitution. Now we have x equals 3 minus 2y. So my first step, wow, okay, I need to isolate, these are vocab. Isolate x or y is the first thing. But I already have x by itself, so our lives are a lot easier. So I'm going to take this x and put it in here. So now I have 3 minus 2y plus 2y equals 5. So now when I simplify though, let's see, so 3 minus 2y plus 2y equals 5. What's negative 2y plus 2y? Yeah, that's just 0. So I end up with 3 equals 5. Now, is this true? Well, the last time I checked, it is not true. Sad face. So if this is not true, are you going to have a solution? No, you're not going to have any solutions. Because when I substituted my x in there, result was not true. And let's check that. So using our handy dandy Desmos, which I love so much, we're going to type in these equations and see what happens. So I got x equals 3 minus 2y and x plus 2y equals 5. Okay, so as I can see, these are parallel lines and they have the same exact slope, so they're never going to touch, which means this does indeed have no solution. Now we're going to try using an equation where the x and y are not already solved for. So we're going to start with negative 4x plus y equals 6 and negative 5x minus y equals 21. So unlike the ones that we did before, x or y is not by itself. So I need to do that here. Let's see. So normally I looked and try to see like which one is easier. In this case, they're about the same. Maybe it's a little bit easier here. Let's see. So I would look and say, okay, my x's both have coefficients, so that's going to require division. But my y's are both either 1 or negative 1, so I won't really have to do any division for that. Now, technically, you could use either one, but I like to make my life easy. So as you see here, I got a plus 1y, and so that's going to be easiest to get by itself, in my opinion. All right, so we're going to say negative 4x plus y equals 6. And wow, I only had to do one step to get y by itself. We got y equals, oops, that's 4x. 4x plus 6. And I'm done. So I'm going to take this 4x plus 6, and I'm going to send it over to my other equation. Can you see that equation? So now I'm going to put this into my other equation. So I got negative 5x minus y equals 21. Okay, so I'm going to replace my y with that. So I got negative 5x minus, okay, so this is another case where parentheses are really important because this negative sign is not just for the 4x, it's for everything. I got 4x plus y, and I might run out of room, oops, plus 6, not plus y. I might run out of room here. Plus 6, equals 21. Okay, so because I have this negative, I have to distribute that because that's negative 1. So I get negative 5x minus 4x minus 6 equals 21. And I kind of ran out of room. So I'm going to write this in here. So negative 5x minus 4x, 6 equals 21, plus 6. I get negative 9x equals 27. If you run out of room, you can write like in the notes. Let's see. You can write in the notes part, like underneath your slide, there's like this little presenter notes thing. You can write there. Okay. So divide by negative 9, divided by negative 9, and I should get y equals negative 3. Or sorry, what am I saying? X, not y. Okay, so I already know x equals negative 3. Cool. So I'm going to take that, and I'm going to send that back to the first equation. So I got negative 4x plus y equals 6. And really, if I wanted to, I could just put it in here, but whatever. Okay, so negative 4 times negative 3 plus y equals 6. So I got 12, because negative times a negative, plus y equals 6, minus 12, minus 12, y equals negative 6. Cool. So that tells me that my thing should be negative 3, comma negative 6. Let's see if that's true. So I'm over here, and I got my handy-dandy Desmos again. And I'm going to stick my equations in here. So I got negative 4x plus y equals 6. Okay, we're good so far. And negative 5x minus y equals 21. Cool. So once again, I see that they go through the same spot. On a side note, one nice thing about Desmos is, okay, so I have the black line selected, so I can look and see what my x-intercept is and what my y-intercept is, because these dots appear. Also, like if I click on the purple one, the same thing happens. So that's a really handy tool for Desmos, and one of the reasons why I like it. All right, so on this next part, we're going to try a word problem. So I have the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? So if you notice, I underlined or circled or whatever the important information. This is good because a lot of times when you are given a word problem, you're given a lot of extra information. In this case, we're not, but sometimes they'll give you extra information that you really just don't need. And so it's kind of good to weed through it in a way that you can point out the important stuff. So we know that for children, so children have to pay $150, and adults have to pay $4. So 2,200 people and that much money. Those are fives, not S's. So we need to figure out how many children and how many adults attended. So the first thing we got to do is set up our two equations. So we're talking about two different things. We got money and number of people. And since we're talking about those two different things, these are going to be our two different equations. So talking about money is one equation, talking about number of people is the other equation. So I can say, okay, so I know that, let's make our word problems first. So let's say, here it's bigger, x equals children and y equals adults. Children, adults. No. Not that really matters. Okay. And I know that the total number of 2,200 people is how many people got there that day. So what is this total made of? Well, we have the number of people is the number of children and the number of adults. And that's what our C and our A represent. So our 2,200 equals children, number of children, plus adults. And that's our first equation. Okay, so we got our first equation talking about the number of people. Now we need the one talking about money. So we know that it's going to equal this amount, but how do we write that? So we got 5,050 equal to, well, I know that C is the number of children, but knowing the number of children doesn't give me the money per se. But for each child, they're paying $1.50. So 150 times C plus $4 for adults. Because how would you figure out how much money was spent on children? You would multiply the cost of the kid times how many kids. So now we got our two equations. Okay, so I got my two equations, and now I need to solve for one of them. So my x is C, and my y is A. So we got to solve for x or y for one of these. And let's solve for C. So we got 2,200 equals C plus A, subtract A. And I know what C is. So now that I know A, I can put it into my first equation. So I get 5,050 equals 1.5 times 2,200 minus A plus 4A. You can actually see. You have to write plain and small. Okay. I'm ready to small. Okay, so now I have 5,050 equals, now 1.5 times 2,200 is 3,300. Minus 1.5a plus 4a. Oh, that's what I did. And 4 minus 1.5 equals 2.5. You have to run off here a little bit. Okay, so this is actually the second time I did this problem, and I realized the mistake I made. When I rewrote this problem off to the side, I had written 5,500 instead of 5,050. And when I got to the end, I was off. So I had to redo it. And I couldn't figure out what I did wrong, but now I realize I rewrote the problem wrong. So that's something that's really easy to do. And I mean, like, I knew how this problem was going to go, and I still made that mistake. So just watch, and like, if you are like rewriting things in other places, just make sure that you write the right numbers. And when you go back and check, make sure you wrote down the right numbers and stuff. Anyway, so now we got 5,050 minus 3,300. And we get 1,750 equals 2.5a. Divide both sides by 2.5. Sorry, word problem. And we get, and yeah, I definitely don't know that off the top of my head. So 1,750 divided by 2.5 is 700. So that gives us 700 equals A. Okay, so that tells me that I have 700 adults. So now I need to figure out what on earth the number of children is. So I know 2,200 equals adults and children. Adults are 700, so I should get, subtract 700, and 2,200 minus 700 is 1,500. Or sorry, 1,500. I don't know why Americans say 1,500. It's probably not a good habit to do. So I will try to avoid doing that. Okay, so that tells me that my point should be 1,500, comma 700. So let's see if that's the case. So one nice thing about Desmos is that I can type notes. So if you press this plus button up here, you can type a note. And so I just made a note to myself that children is C, and that's the same thing as X, and adults is A, which is Y. Because if you type in our equations of C and A, Desmos is not going to know what you're talking about. So we're going to need to type in our equations with that x and y. So we got 2,200 equals adults plus children. Oh, sorry, x plus y, literally specific. And then 5,050 equals 1.5 times children, oh my gosh, x plus 4 times y. And I've already zoomed out. When you start Desmos, you're like very zoomed in, so it'll look like this. Well, actually even further in. But when you have such big numbers, you gotta zoom out a lot. So I zoomed out a lot. And another nice thing, I can click right there, and I can see my intersection. And the intersection is exactly what I got. So this tells me that I did the right thing.
Wow.